Hello everybody, it's Mike Levin on Friday, July 29th, 2022. And I just did a fresh restart in order to show you this next step from scratch after a reboot. We had just gotten a Linux service running under a Linux container under Windows 10. Now we are going to make it able to be watched while it's running. So, first step is to just pull up this, which happens to be Ubuntu 18.04 running directly under the Windows subsystem for Linux. So this is the Windows terminal program. And I have managed to get the LXD container system running here. And so we can just do LXC ls to list them. It would also work with list. So ls and list are both the same exact command, really. You'll see that I've got three containers: Looking Glass, Munchkin, and Quadling. The last one I've been working with was Munchkin. So I know that after a fresh restart, the last one you were using will restart as soon as you start accessing these things. So there it is. Now it has an IP, and we can actually get into that. How do you get into that? Well, you use the LXC command for executing a command on one of the containers. So execute on container Munchkin. The command switch user, no hyphen space switch user. You need that hyphen to delineate the command that's coming. And then it's going to be login as user Ubuntu. Now, see this long colorful prompt? When I hit enter, it becomes a short, less colorful prompt. We switched from being user Helus at Lundervond to user Ubuntu at Munchkin. And we don't need all this stuff here, so I'll clear and make the cursor bigger. Now, we wrote a service called Pulse the other day, which lives inside of cd/etc/systemd/system. So we cd there, and then we can look at what's in there. We wrote this service here, Pulse service. It's the only one that's white. That's because all the other ones are directories or symlinks that have just been copied into place. The way these things are usually managed is they're kept other places, and then symlinks are copied in and out of this magic location, /etc/systemd/system. That doesn't keep us from writing a file directly there. So let's take a look at it. Vim pulse service. This is the thing that turns a file that's sitting elsewhere on the drive. Where is that? Well, it's in this location here, and it's a file called pulse.py. We'll look at that in a second, but this is the file that turns it into a service, right? So restart every seconds. If it ever quits, every 5 seconds it monitors it to make sure it's still running, and it'll restart it if it's not. That's a big part of what makes a service a service. But it's written to be a long-running script. These things here are written to be long-running script. It's in simple mode, so simple mode knows that there's just a long-running script that doesn't have much interaction. It doesn't need to be, run multiple times, all these things, so that it can be in simple mode. And what does this do? Well, it simply writes out a file into the temp location, and we can try taking a look at it. First, we'll take a look at, where that file is for the Pulse service. So we'll now cd into home directory, GitHub, Pulse, and we'll ls in there. That's the file. We can vim Pulse. This is the other side. There's two files in the service. There's one file which is the code that gets run as the service, and then the other file which says this file is a service and you ought to run it, and here's how. So this is just writing into /tmp, which all Unix-like operating systems have as a temporary file writing place. It's writing into pulse.txt in append mode the time. So time is just a magic little thing here that turns now into a string. So if I were to do something like that out here, I could just type the date command. That's just a timestamp. So I'm basically just writing a timestamp into a file over and over. And we could try taking a look at that file by tailing /tmp/pulse.txt, and it's not there at all, but we can make it be there by actually running the program. So we can go Python 3.10 pulse.py, and the pulse service has started. Every 5 seconds or so, it's just going to write out another timestamp. We'll wait for 4 of them to go by, and then I'll Control-C this, and we'll take a look at that file with the tail command. Control-C, and there's the 4 lines written into the file. Now, I can delete this, remove /tmp/pulse, so that if that file runs again, I'll know it by looking at that output file. But this output from the program here locks up the terminal. If I were to try and run this from here, it locks up the terminal. I could open another terminal and look, but that's like kind of what services are. They are running invisibly most of the time. So we can start the service by doing sudo systemctl. Now I happen to know I've disabled it, so we can actually do, before we even do that, we can do systemctl status pulse and see what the system thinks about it. It's disabled, blah, 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 blah. So we'll enable it. When you stop, start, enable, disable, you need to sudo the systemctl commands. Enable. But enabling pulse doesn't turn it on. If we tried to look at the output of this, it still wouldn't be there. So we need to sudo systemctl start pulse. Now it started. This is where we're at the end of the last video. We have a service. That service is running. We can't see its output like when we ran it directly from the Python interpreter, but it's running. How do we know it's running? We can tail that. There it is. The last one is 068.018. We run tail again. It's got another entry. And because it's the tail program, when it gets up to, by default, when it gets up to 10 lines, it'll start just showing the most recent 10. So I could sit here while at 1, 2, 3, 4, 5, 6, 7, 8. I think that's up to all 10 lines now. 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, no. There, now it's up to all 10 lines. And the last line is 101.338. It's going to show the next 10, and every 5 seconds there's a new thing down there. So we know it's running as a service in the background. And that would just make that file larger and larger till it, crashed the system from filling up the memory, not the drive, but the memory, because /tmp gets lost after every power cycle. That's why it's a safe place to write things into, because it won't cause cruft or garbage or trash on your system. But it still could fill up memory. I'm just doing this for expediency to test this stuff. So if I were to vim /tmp/ pulse, you would see all the lines. You could go up and down it, right? There's more lines than are showing by tail. All right. But you can't actually watch the thing run, right? There's more lines, but you're not watching it run. You're just looking at the output of the program. What if you wanted to watch it run? Well, a reminder that let's stop the service. Sudo systemctl stop pulse. It's not pulse.py, it's stop pulse. And then, in fact, I'm going to disable it just for precautionary measure. And then I'm going to remove /tmp/pulse.text. So now we know it's really not running. And as a reminder, if I were to run this the Python way, I'm not going to do it again because it would require all that deleting the file again. But I could totally do this. And this is what the service is doing. But when I do this here, it locks up this terminal. And when it's done as a service, there's no way to watch it. That's where a program called screen comes in. but screen is not installed by default on these very minimal images that are created when you pull them out of the image server from Ubuntu using the LXC command. LXC, what do they call that? It's such a strange term they use. But you LXC launch, and that pulls it from out of their image repository, puts one local, but it's very stripped down minimal. It doesn't even have the screen command. So we fix that sudo apt update just to make sure we have the latest of all the repository software out there. This updates the local copy of all the software that's available that you can pull down. And the thing we're going to pull down is sudo apt install screen. Now we'll do a before and after. Oh, we did do the before. Screen command not found. So sudo apt install screen. The before is sitting right up there. All right, so it is installed now. And we can use some of my knowledge from beforehand to go screen ls. Now you might recognize ls as the way we looked at our various virtual machines. This is a recurring theme. Ls or list is often used to list things. And in fact, there are some parallels between screen and container technologies. This is kind of like containers for just terminal sessions. There's a lot of ways to think about this stuff. And it's always similar. It's APIs of isolation and stuff. So we have screen, and I'll demonstrate screen by doing screen -R, which will reattach to a screen, but because it's a capital R, if it doesn't find it, it'll create it. And we will reattach to screen foo. Now look at the colors, green, blue, all this lovely color coding. The defaults of the screen program just blow away that color coding. You can always get it back. Oh yeah, see, it's green and blue. That's very interesting. It's more colorful than I remember from the past. Yes, that makes it harder to know you're in a screen terminal. Lovely. But if I were to exit out of it, screen is terminating and we're back to where we were. It's going to be a little bit difficult to know when you're in a screen or not, but I'm going to do that again. And we are now inside a screen. You can see that new screen getting created. We're inside of it. But even from inside a screen, you can do screen -ls. And you can see now that we have one screen running and it's attached and it's called foo. If I hit exit, it actually exits this screen terminal session and goes out to the parent one, and then foo is no longer there. There's magic control keys. You're just going to have to learn them. It's Control A, and while still holding down the Control key, it's the next modifier key. And I did D, so that was Control A and Control D, which detached me from foo. Now if I do screen -ls, you can see foo is still running, but it is detached. It's just floating out there in the abyss. Oh yeah, prove this to me. Okay, this is how we prove it. First we do a before. We'll try and tail tmp pulse.txt. It's not there, okay? We're going to go into this screen here. So that's screen -uppercase R, though lower would do now because it exists, foo. And that drops us into that screen. Clear. And we will Python 3.10 space pulse.py run. Now, do you remember before how we were sort of locked up and we couldn't, say, do anything else? Well, we're not locked up anymore. If I wanted to take a look at that tail file as this was running, I Control A, D in order to detach from it. I can clear. But now if I screen ls, you can see it's still running there. And then if I look at the file, there's the file growing longer because it was deleted, but now every 5 seconds in the background, it's running. Want to watch it? You just reattach to it. Screen reattach foo. there it is running. You are monitoring this running process. It is not a service because of the way we ran it. But wouldn't it be nice to run the service like this so we can monitor the service? Yeah? All right, let's do that. So there's no reason to have it running twice. So we will, in fact, Control-C out of it. Control-C'ing stopped the script from running. And now we can exit. And so the script has stopped running, and we've exited out of the screen session. So I'm going to try and get in the habit of doing Control-L instead of typing clear, thanks to a user, Jens Ole Freeman, if I pronounce that right. If I got that wrong and it's Jens, I apologize, but it looks Scandinavian. So Jens Ole Freeman tells me that Control-L is clear. And I'm going to do that a lot more often now. And remove tmp/pulse. I believe the service is disabled now. Systemctl status pulse. So yeah, it's a disabled service. I remove the output, and there's nothing going on service-wise with pulse.py now. It's, or with running it manually through Python. That's all stopped. We now vim that file that's in the service location. So that's vim. It's sudo. My fingers know better than my mind. I have to sudo vim because it's in a privileged location. That privileged location is /etc/systemd/system. Command line completion will work to tell you you're right. Pulse, the file named pulse. Now we're going to change a few things. This simple mode that it's in can't stay that way. Simple mode kind of locks it up and keeps you from being able to use the screen program. So we're going to change from simple to forking. I just know this from beforehand. This is tapping stuff I know from prior. So you're just going to have to take my word for a few of these things. These are the magic incantations. These are why everyone isn't working this way. Now I think it's I'm going to have to figure it out because long paths are better than short paths. So I'm going to save that for a moment. I'm going to quit out of it, but I'll be back here in a second. I just need to confirm the long path location of screen. So cd/user ls cd bin ls sc asterisk, whoops, sc asterisk. Yeah, there's screen. It's in user bin. Okay, so we will edit that file again. Doesn't matter what directory you're in when you start editing, when you give it a full path, but I know it's user bin screen. That's very important for this next step because these things love full paths. User bin screen. And then we're going to need a few modifiers. If I remember correctly, it's D, just to detach in case it exists. It's M for forcing it to start, even if it's nested or from a system service or stuff like that. And then S, I believe, to give it a name, and we're going to give it a name Pulse. It's just going to, service is going to be called Pulse when we look at or the screens, that's the screen name because that's a parameter of the screen command. So we're doing screen -dms space pulse to give the screen a name, and then the full command as it used to be executed, because all you're really doing is you're executing a command from within the screen. This is very reminiscent of, how we log into a container. Container and screen have a fair number of parallels. So we changed that to forking. That was very important. We put the command in to funnel the command we were also doing through screen, and I think that's it. We escape key, write, and quit. Okay, so Control-L. Now, here's a really interesting thing. we're going to have to restart the services, and not just a restart of the service itself. We have to reload the daemons. Okay, so let's do that. Sudo, because it's a privileged operation, systemctl, because everything goes through systemctl now. I started making mistakes earlier in my videos using the service command because of older days, but I got to get myself thinking on systemctl for everything systemd. If you're thinking systemd for this whole daemon management system, think systemctl for all these commands to manage these things. So this is an unusual one, daemon reload. But when you edit those files, daemon, D-A-E-M-O-N, when you edit those files that tell it like whether it's in simple or forking mode, you have to do this to force it to reload into memory. And now we actually can then enable it. And then we can start it. Now let's do a before and after. Tail tmp / pulse.txt. There's no file there, okay? And then the other before and after is actually screen-ls. There are no screens showing, all right? So now sudo systemctl start pulse. It didn't complain. This is going to be a good video. So these before and afters, we tail the file. Is it two things written? Can we watch that service running? Screen ls. There's a screen called pulse that wasn't there before. See, no sockets found. We started the service, and now there's a screen. Screen, we'll use lowercase r because it's there. We know it's there. Uppercase R would force it to exist, but because it's a service and, we don't want it to force it to exist, we want to only go there if it was created properly. Pulse. Look, we are monitoring the service running. This is the console output from the service. Here's a 5.8. Here's a 3.0 being written. Control A, D to detach. And we'll tail that command. There's the 3.8. We wait a moment. There's a 3.5 there. It's running in the background. We can tail it to see the output. This is just the output from that file inside the temp directory. We're just showing the last 10 lines from the temp directory. But if you actually want to watch it running, there it is running. All right, so you can't control C from here. If you control C from here, it will actually exit out of this, but because it's a service, that's actually worth doing. Control C, watch. Control C, and it even exited out of the screen. So if we do screen ls real quick here, it's already back. And we'll go into it, but see how many fewer lines there are? Let's Control C and then screen ls real quick. No sockets found. Screen ls again. There it is. It's there. See? The service is recreating it. This is systemd. This is the wonderful thing. This is so much more important than, say, web development. This single trick I'm showing you here, 23 minutes into the video, this is more valuable than anything. This is making a Linux machine do your bidding. This is Mickey animating the broom in The Sorcerer's Apprentice. This is better than, I don't know, apt install Apache 2 or Nginx or any of the other web service things you could do at this point, which everyone is going to guide you to, getting Node on your machine, all this nonsense stuff. But, I have now a system. I'm going to cd to home, make it look real simple. Okay, I have a system which is a container under Linux. It's a Linux container. So if I were to go to another machine here, go to its, the Linux host, and to lxcls, you can see here, this container called Munchkin that's running is what's over here. And inside of there, we have services running in 24/7 mode. If we were to take this and put it in a cloud server, it would run exactly this way in the cloud, doing whatever useful things we needed done for us. But the service that's running is now accessible through the screen API because we tweaked out, we exposed a terminal in which it's running so that it's not running in this kind of invisible mode directly by the systemd process runner. The systemd process runner, instead of reaching for the Python executable, it is reaching for the screen executable. And the screen executable is being told to run this file through Python. And now we can screen our pulse. And there it is. And then there's all kinds of Control A commands. There's a history up there. So Control A, I don't know, escape, copy mode. And there, see, I can scroll up. The pulse service has started. So you even have kind of like a an interface to go through your history. You know, it's almost like a log file. You want to be careful because, you know, again, you don't want to fill up memory, and there's going to be a limit to how far up you can scroll in these things, but it does have a history. The escape key gets you out of copy mode, and yeah, you got to be careful. This is a terminal, so that's a running script. So, you know, I sent some input. It didn't interfere with the running of the script, but you do have to be careful. Control C would stop it. So you need to know your Control A combinations. Control A, D for detach. So we detached from that screen, but it's running as a service in the background. And in fact, this is interesting. As an added bonus, we'll use the LXC commands here to stop Munchkin. LXC, yeah, that should work. Error not found. I have seen this once before. I don't know why that's happening because I know I'm spelling it correctly. LXCLS works. LXC stop. There, okay, it found it that second time. Explain that to me. It's the exact same command. So these things are MUNCHKIN. I even spelled it the same. So I can stop it. Now I'm going to look over here, and in fact, I'll go into the screen of the pulse command there, and I'll stop this, and then I'll run over here, and you can see log out, session terminated, and it's not only logged it out of that screen session, it knocked it all the way back to Lunderwand. You can see Ubuntu at Munchkin, that was inside the container. By stopping the container, it stopped everything and even logged us out here. Now let's start the container again, and we'll see whether the magic is really fully magical. Because now that that's started, we can log back into it here. The last command should have been the login. There it is. We can just go into it. And now screen ls to see the service started again. There it is. That's completely magical. That's completely magical. Screen reattach to pulse. And there it is. You can see fewer lines there, but after the container was stopped and started, the service comes back and starts running in a monitorable fashion. This is such a good, important video, fundamental knowledge of the way Linux works now that the world has settled on systemd. This is relatively new, but it's relatively new plus fundamental. This is how you control system services running in a 24/7 relaunchable and all that stuff. Of course, one of the things you could run is a web server, but you don't have to dive into web development at this point. You can just do simple stuff on scripts. What I'm doing so easily here with just writing out the date time could be anything, right? CD GitHub pulse vim pulse. This Python here is the service. That could be scraping websites or whatever you want, the sky's the limit. You don't have to know arcane Linux bash script knowledge to write a script. You do have to know how to make Python long running. This trick right here is important, and things like this to make sure it's not a busy loop. But once you get down how to do a long running Python program, like schedulers and stuff, this is a breeze. It's a wonderful way to manage Linux services. I do it for work all the time. I'm about to take my next big step forward that requires doing this. You can imagine a heartbeat that just emails you once every 6 hours or once a day to let you know the server's still alive, all that kind of stuff. So that is this video. Wow. It's really hits the point home here. This is starting to culminate a lot of recent work. So thanks for joining me. Don't forget to subscribe and hit the like button if you like the video. Hit the bell if you want to see my live stuff when I start live casting, and I'll talk to you all soon.